Alright guys, so today we're jumping right back into our spiders and we're going to do we're in the unit of traits and reproduction 1.5, so this is the last lesson of this chapter. So after this we're either going to have a review day based off of your guys' self-assessments. I want you guys to be totally honest with those, that's not till the very end. But if you guys feel like you really understand what's going on, then we're just going to jump right into chapter 2. Or I might take a day to review, to cover some things, go over a few things, and figure out, we need to, figure out areas that we're not sure of. Maybe you're not sure of the difference between traits and features or whatnot. So after this lesson, you'll be able to tell how you feel. And you want to make sure that you're completely honest, because if we keep going, because you said that you fully understand, then as we keep going, you're just going to become more and more confused, and then I'm going to look at you like, I don't know why you're confused. You said you knew what was going on. And we don't want that, because then whenever we have to do our science work, we're going to get that ugly feeling in our gut, or that feeling of, I just don't want to do this, it doesn't make sense, and that's not fun. And that makes school take longer, and it's just blah. Nobody likes that. So instead, it's better if you're honest with me and just say, hey, I'm confused in this area, or I'm confused but I'm not exactly sure where, and that way we can work it out, and then when we jump into the next chapter you're like ready to go, you fully understand it. Questions are good, remember mistakes are good, it shows us that we're learning, okay? So these are the things that you need to have open today. We are going to be working in Amplify again, so have your Amplified open, and then there is a docs that is called Traits and Reproductions 1.5 reading chart. There's it either says 8th grade or 7th grade, whichever one you're in, and so make sure you have that open. It's just a list of names and there's a bunch of colors. And then we will be jumping into a Google discussion. So in your Google Classroom, I have everything organized, and you usually click on your daily assignments, which is how you got to here. You clicked on your daily assignments, and then you were able to, sorry, my eye is itchy. And then you're able to jump around. There's another category that says discussions. So in your discussions, it says traits and reproductions 1.5. And if you want to have that open so that you can jump straight into it when we get to that point, that'd be totally fine. But if you just want to wait for that part, it's up to you. Whatever you want to have open that makes this easier. We're going to be jumping around a little bit, so just follow along with the video and it should go smooth. If you get confused, like always, you can always message or comment me, or if you need extra help, we have our Zoom meetings at 2:30. So go ahead, pause the video, make sure you have everything opened, and then we're going to jump right into Amplified. So when you click on the link of Amplified, you should be right here. And when you're right here, you'll just go ahead and click Warm Up, right? Because that's what we're jumping straight into. And our warm-up is pretty short today, so it says Dr. Satari and the genetic researchers at Bay Medical Company have determined the proteins of each spider offspring. Review the results and then answer the question below. So we've already seen this chart, but they've added something a little extra. So if you can look at it and tell me, what do you think is different? We have the parents and the offsprings, but if you look right down here, what are those? They should seem familiar because of your simulation. Think of the connects. So these are your guys' proteins, right? So they have added, the researchers have gone deeper and they've been able to look inside of the spider cells at a macro scale. At a molecular scale, right? It's fairly small, so we're looking at it at a molecular scale. And they're able to say, oh, these are the types of proteins that each of these have. And so these proteins, remember proteins, the way the proteins are structured affects the function, which affects the silk's flexibility. So now we're going to go down here and it says, the genetic researchers at Bay Medical Company are interested in spiders with the trait of medium silk flexibility. They think this is a silk that can be used for medical purposes such as making stitches and for creating artificial tendons. Why do you think offspring B has a medium silk flexibility trait? So we have, this is B. So look at all of the siblings have different flexibilities, right? I mean, A and C are the same, but B and D are different from everyone. So why do you think offspring B has medium silk flexibility? Does it have to do with his parents? Does it have to do with his proteins? Does it have to do with his siblings? So go ahead and pause the video, jump onto your Amplify, and tell me why you think offspring B has medium silk flexibility. Alright, so now we're going to go on. You should be able to click hand in, and then the next activity button should pop up. So now we're right here, and you can see that it says Darwin's bark spider claims. So we have been trying to answer the question of why do traits for silk flexibility vary within family of Darwin's bark spiders, right? So we know, we just looked at the tree and saw that the parents had 4 spiders and they're all different. And so why is that? So here are some ideas. Claims are just hypotheses, ideas of why this is. So claim 1, the offspring have mutations that affect their traits. We haven't gotten into mutations, so we don't know if that's true. Claim 2, the offspring's traits depend on which parent the offspring received more traits from. You know, that's something that you guys can dig into your brains and dig a little deeper and say, when we came back from spring break, we were talking about traits and alleles and all that. And we talked about how many you get from each parent, right? Remember the Punnett square? So kind of think about that. We'll go deeper into that if you're like, those Punnett squares made no sense to me. That was totally fine. And then claim 3, the offspring receive different combinations of traits from their parents. Is that possible, or do we all get the same traits from our parents? Okay, I want you to think about your siblings. When you know your parents had all of your siblings, you both came from your mom and dad, and so you look at them and you say, okay, we don't look alike. You know, you have similarities, right? You might have the same hair color, the same eye color, maybe the same nose, but you have a bunch of things that are different. Even those of you that are twins and triplets, there's something different, you know? Maybe you have a freckle in a different place. Maybe your nose is slightly more up than your sisters or brothers. These are all things to think about. So let's just look at the family tree that we were looking at just a second ago. And here it is again. And so with this, we see that we're interested in the medium silk flexibility because the researchers and doctors think that's what's going to be best for fake tendons and stitches. So why is B the best? Why is it a medium silk flexibility? So you guys gave me your answer in the warm-up, and now we're going to look. Think back about the video with the connects. Okay, so each of these little lines represent a connector. So when I connected the connects, we saw that, well, the one that was just the stick, like this one, it couldn't connect to any of the ones that it was like. But it could have connected to this one, right? But it would have very little connectors. So if I was to put this stick on top of here, these two areas would be really stable, but the middle would be wiggly and jiggly and moving all over the place, right? Now this one was like protein 2, and we saw that it had connects in all the areas. And so this one has 4 connects. So if these two combine together, it's going to be really stiff, right? There's not too much room for it to wiggle and jiggle. Now if we look at the medium one, the one that we want, if we were to put this one on top of this one, it would connect in only a couple places, right? So it would only connect in these areas. So there would be more room for it to wiggle and jiggle, but it wouldn't be too much, right? It would stretch, but at some point it would snap. It wouldn't be like putty or melted gum on a hot Bakersfield day where it just keeps stretching and stretching, or hot cheese, you know, when you bite into your pizza and it just keeps on stretching, you're like, oh geez, I need this to stop, and then it flings onto your face and it's really hot. We don't want that. We want just the right amount of stretch so it's ooey and gooey, but just the right amount. So that's why the medium silk flexibility is the way it is, because you have the proteins and they connect together, but they're not too flimsy, but they're They have some structure to them, but they're not stiff. They're able to still move around just enough. So now let's go down to our key concept. Our key concept says organisms can have different proteins in their cells for a particular feature. So what this is saying is that inside of our cells, there's all different kinds of proteins doing all kinds of different things for different features. Right now, we are pinpointing out that the spiders, we're working with their silk and their flexibility. So we're talking about those specific proteins. But that's not the only proteins that are in there, okay? And it's not just for spiders. All organisms use spiders, okay? We use them, and we have proteins that tell our eyes what colors to be. We have proteins to tell our hair what color to be. We have proteins that tell our bodies how fast we're willing to move, how slow our bodies can move, all of these things. And it's not just for spiders and humans. It's for lions and bears and all kinds of things, right? Lions and tigers and bears, oh my, like everything, anything you can think about. Butterflies, ants, dogs, cats, these are all they're all made with cells that have different proteins who are structured a specific way to make sure that they function properly. I'm using specific words, guys. I hope you're catching on to that. All right, so let's go ahead and let's go on to our next activity. So I'm going to go ahead and pull these down. And then I want you guys to just go ahead and hit next activity. So here we're going to be working with a simulation. Sorry, guys. And previously we worked with a simulation, and in that simulation we were able to see the proteins inside of it, see what they were doing and what their jobs were. And then we were comparing different traits to same features, right? So we were looking at all of the silk flexibility, and we were saying, oh, this one has this feature and this one has this one, but this one has this kind of protein and this one has this kind of protein, so that's why they're different. Now we're going to go a little deeper, and we're going to say, what happens if we change those proteins, right? What if we mess around and decide something different? So go ahead and open up your simulation. Or I'm sorry, they call it just a sim. I always call it a simulation. And we're back here with our good old spiders, Greg and Zora, right? We were working with those quite a bit. So we're going to work with Greg, and we're going to talk about his silk flexibility. And so we're talking about his silk flexibility, and we see in here all of his proteins floating around. And so with his proteins floating around, I want you guys to go back into your main Amplify and scroll down, and you're going to see a chart. And I want you to work on column 1 really fast. Before we get too far ahead, it says, what traits and proteins does Greg have for silk flexibility? So we come here, here's his proteins, and here's his trait. So I want you guys to tell me, does he have low, high, or medium flexibility? And what kind of proteins does he have? Does he have protein 1, 2, or 3? Are they going to connect really well together? Are they barely going to connect? So go ahead and tell me what Greg has. Pause the video and do only column 1. Alright, so now we're going to do column 2, and it says, do you think adding protein 1 will change Greg's trait? Why or why not? So here we go, and we see down here, we have protein 1, 2, and 3. So if we add more protein 1, right, because it kind of looks like what he already has, so if we add protein 1, what is it going to look like? Go ahead and don't do it yet, but I want you to tell me what you think is going to happen. What's going to happen to Greg's silk flexibility? Is it going to change? Is it going to slightly change? Is it going to stay the same? What's going to happen to it? So go ahead and pause it and do that. Alright, so now we're going to go on to test our prediction. Did you observe a change? If so, record the new trait you observed. So this is the real thing. So right here we're going to come back and we're going to go ahead and add it. Let's go ahead and just add it right in there. Boom. We added protein 1. We're going to wait a minute to see, because you see it's adding. This blue line is saying that we're still adding, and we're done adding. So what happened to his trait? Look over here. All right, and when we're going to look up here, pretty sure it kind of still looks the same, right? It got an asterisk, but that's about it. So now I want you guys to tell me, go ahead, pause the video and tell me what just happened. And we're going to move on, and as you guys scroll down, you guys are going to be able to see that there is more data for you to be filling in. And so now what I want you guys to do on your own is show me what you're going to observe. So right here, we are still talking about Greg's flexibility. So you're just going to come back and we're still here. We're not changing anything in the simulation. And I want you, so pretty much you can look at the first box you filled in and you can just copy and paste because it's the same thing right here. Now where it says, do you think adding protein 2, we're working on 2, right? So the first one we did protein 1, so we added the same kind of protein. Now we're adding a different protein. We're adding protein 2. So will it change Greg's trait? Why or why not? So go ahead and you're just going to click on protein 2 and slide it on in there. Well, first you have to make your prediction, okay? Do that first. Tell me what is going to happen. And then go ahead and test your prediction. Slide that number 2 right on in there, and then wait a minute and wait to see if something happens to his trait. And if nothing happens, tell me. His trait stayed the same even though we added protein 2. If his trait changes, tell me his trait changed and now he has this kind of silk flexibility. So pause the video and get that chart done. And we're going to move on to the next part, and it says Ruby's body color. So we're going to move on to Ruby's body color. So this again, you're just going to come back into your simulation and you're going to click the X. And then we're going to work with Ruby. Woo! I haven't worked with Ruby. Here she is. Look at this bad girl. She's a female. Her trait is medium. And now I want you guys to make sure that you read your instructions. It says, what traits and proteins does Ruby have for body color features? So you want to make sure you come up here and you change body color. Whoa! There's all kinds of stuff going on in her. So I want you guys to explain to me what her proteins look like, okay? So you have protein 1, 2, and 3 down here. Which ones do you see inside of her body? Does she have one single kind of protein? Does she have multiple kinds of protein? So go ahead and clarify that. Then move on to the second part. If we add protein 1, will that change Ruby's trait? So here's protein 1, you're going to add that one. But before you add it, tell me, what do you think will happen? Is she going to stay the same or is she going to change? And then test your prediction. Go ahead and slide that bad boy in there. Wait a minute, watch it, and see if Ruby's trait changes or stays the same. Go ahead and pause the video and go ahead and get to that. So now we're going to go ahead, you guys should have this all filled out, and we're going to hit hand in and move on to our next activity. So before we jump into this, I just want to cover something a little bit. When we were working with the spiders, we saw that we added stuff and things were changing, right? We saw that Greg's trait changed when we added protein 2, Ruby's, I'm going to wait to see what, after I read your guys' stuff so that you guys don't go back and change it. Did it change or not change? But did the changes stay? Remember when we did it, the first one together, it got a little asterisk at the top and then it went away. So what happened is it changed for a moment and it was temporary, and then he went back to his normal trait. And that's because when we inserted a new protein, that's something that we artificially put in there. So we looked at him and we said, okay, we're going to add this protein. But then after that protein was all used up, he's not creating that protein. We inserted it inside of him, right? We're talking about Greg the spider. And when we inserted that protein into him, then that was it. once it was used up, it was used up, and his body continued making the same protein that he was already making. So that's why it's not sustainable. It's just a temporary thing. Adding does not change what the spider naturally produces. When we add it in the sim to learn and understand how the different proteins change things, right? How the structure of a protein affects its function. So when we added a different protein that had a different structure, it changed the way his silk came out, right? But because it had a different function. And so this is something that we can do in simulations to help us understand things, but in the real world, it's a lot harder to do. We can't just go inserting proteins into different people and be like, I want you to have blue eyes, and, stick proteins, that make blue eyes, and then sit there and watch their eyes change colors. That's not reality, but in simulations, it helps us to understand the way proteins work. So don't go trying to change proteins, okay? We're not that far yet. Maybe once you guys make it to Princeton or Harvard, you guys can do all that kind of stuff. And so now we're going to move on to this little area right here, and we have been giving a new letter, and it says student researchers. That's us, because we're going to be scientists. And it says, at Bay Medical Company, we are working on several projects. So far, you have been helping us with our spider silk research. However, we now want to introduce you to another project. Oh man, we're about to get serious. One of our teams is conducting research on human muscle proteins. So, look guys, we finally get to stop working with the spiders for just a little bit. I want your team to take a look at the initial findings from their work with protein called ACTN3. And it says adkinin 3, that's what it's called. Adkinin 3 protein molecules connect muscle fibers, helping them contract more rapidly. Okay, so contract means the muscle can move faster. As a result, the researchers think this protein might help people run faster. The researchers want to know what you think about the results of a test they just completed. They wonder if they should continue investigating this protein or if they should stop. Okay, so this is where I was talking about that Google discussion, and we're going to get a little more into depth. So at ADKIN3, ADKIN3 is a real protein, guys, and so this is what we're going to be working on right now is some research that it is research, but the things that you're going to be reading was not an actual experiment. So kind of keep that in thought. So now go ahead and click next, and we're going to come right down here. And so this is where we're going to start talking about this. You guys are going to read the evidence, and then it says read your evidence, and then do you think that this evidence shows the protein determines running ability? So there's 3 different questions, and there's 3 different readings. So you see we're in activity 2 right here, then there's 3, and then there's 4. So if we were in class, you guys would be in groups of 3, and you guys would each read it, and then you guys would each come together and tell each other what you found. But because we can't do that, I went a little, I'm trying to make you guys still be able to work in a group so that you don't have to do all of it on your own. So for this activity, instead of doing it on Amplified, we're going to be doing it in Google Classroom, okay? So what I want you to do is I want you to make sure that you keep this open because you need to read the evidence and the question. But in your little area right here, I just want you to put in Google Classroom, okay? And then what you're going to do is to figure out so remember I said there's 3 different readings, and it starts with 2, 3, or 4. And it says right here, student 1. And then over here, it says student 2. And then in number 4, it says student 3. So remember I asked you guys to open up your reading chart? This is what it is. So this is the 8th grade reading chart, and then this is the 7th grade reading chart. What I want you to do is you only have access to your class. So only look at your class. Don't worry about everybody else's, okay? And So say you're in 8th grade 2B. I want you to find your name, okay? And then you are going to say, okay, I'm student 1. So what you're going to do is you're going to go back to Amplify, and you're going to say, okay, let me go to number 2. I am student 1 right here. This is where you are looking, student 1. So then you are going to read the test, you're going to read the evidence, right? And then you're going to go into Google Classroom, and you are going to go into your discussions. Now, remember, I said you might have wanted to have this open already, but you're going to read, once you figure out what student you're supposed to be, student 1, 2, or 3, you're going to go into Google Classroom, into discussions, go to Traits and Reproductions 1.5 discussion, and I'm going to have, your little area. And I want you to tell me what you found. But the reason why this is color coordinated, so let me go back to the chart really fast. And you'll see that there's someone in your color. Now, whoever is in your color, you have to leave a comment on those 2 people, right? So you put yours, you say, this is what I found. And then you are going to go in and you're going to find, let's say Jesus writes his. Now he has to look at Kathy and Elena, and he has to say, okay, on both of theirs, right? So they're going to each put their own, and then on both of theirs, he's going to leave a comment, and he's going to say, I had student 1, and in student 1, this is what I found. And then you're going to tell them. And then Kathy and Elena also have to go to Jesus's, and they have to say, okay, I had student 2 and I had student 3, this is what I found. And so in everybody's thing, you should have your own, and then you should comment on 2 other people, yours, and then 2 comments. Make sure, this is all in the instructions as well, guys, so I'll just make sure that you're reading the instructions, okay? And then after that, we will be able to collab and see what everybody learned. So go ahead and pause this video, read your Amplified, right? Read the evidence, and then answer your question. Do you think the evidence shows that Atkin 3 protein determines running ability? Explain your ideas using the words proteins, traits, and feature. If I do not see those words, you will not get credit. So pause the video, read your test and your evidence, go and leave your comment, and comment on 2 others. If theirs isn't there yet, come back later, okay? Just do what you can right now. Go ahead and pause it. So once you've done that, you're going to, like I said, answer in Google Classroom discussion, and then you click Save and Continue. Now we're going to talk about the writing of, this is the same thing. Save and continue, hand in. Next activity. The next activity is your homework. And so it says, revisiting the anticipation guide. Remember at the very beginning of this chapter, the very first warm-up that we did was an anticipation guide. And when I answered some questions. And so you guys are able to go back all the way. You just have to go, I'll show you really fast. If you go to the top, go to lesson brief. Right up here, if you go to chapter 1, you can go back to lesson 1.2. It'll take you right here. Click on the warm-up. And you can see your, what did they call it? Your statements. You can see your statements of whether you agreed or disagreed. So go ahead, make sure you guys refresh your memory on that, and then just go ahead and go back to chapter 1. Right now we are in chapter 1.5. Go back. Go ahead and just click on activity 5. And tell me. Answer the question again. Review your original response. I just showed you how to do that. Traits such as your hair, eye color are determined by proteins made by cells in your body. Do you agree or disagree with the statement now? What evidence supports your ideas about the statement? So now that we've had a little, we've been educated a little more, do you agree or disagree with the statement? If you agree or disagree, you must show me evidence, right? So, and by evidence, it can be you explaining something that we went over. You could be talking about the connects or the tree, the family tree. You can be talking about the Sims, anything that you use to back up whether you agree or disagree. So go ahead, pause the video and do that. Just click hand in, and then it will take you to the next activity. At the top, it says optional. Let me be very clear. This is not optional. When it says optional, that's just for me as a teacher. It lets me know I can give it to you or I cannot. But it is not optional. I really need you guys to go through this self-assessment. It's really short. Look, it's 5 questions. And I want you guys to answer these questions to the best of your ability. Try to use your vocab words. Try to use evidence. And if you don't understand something, tell me a little bit that you do understand, and then at the bottom maybe say, this is what I understand, but I'm not 100%. If you are like 100% on everything, like I got this, I get what proteins do, I get that the structure changes the function of the protein, I understand that the protein can change the traits, you understand that a feature is what everyone has, and a trait is what I have individually, or what the little spider has individually. So if you understand all that, you are awesome, and you're great. Make sure you can tell me that on this self-assessment. And then if you're the opposite and you're a little lost, tell me where you're lost. Try to pinpoint it. If you can't, we'll work on it together. This is going to tell me if we can move on to chapter 2 or not. So that's all I got for you guys. Make sure that you guys have fully filled out all of the activities and Amplify. Make sure you have done your discussion. Remember, in your discussion, you leave your comments, your main comment, and then you go and you comment underneath 2 other people's, right? And it should be in the color. I've color coordinated it, so make sure you're using your chart. And if they're not there, just keep rechecking it. If by the end of the day when it's due, go ahead and turn in and just let me know. Hey, it's not there. And I say, okay, we'll talk to those people later. Right? So Amplify, discussion, and I hope you guys have a wonderful day, and I hope that you are grasping the understanding of spiders, traits, and proteins. Bye guys, have a great